Hey everybody, so today we're going to go over a few things for the law of exponents. This is just our first day with law of exponents, so we haven't learned too much of that today, so we're just going to kind of go over some of the basics. So I'm going to come up with some problems as we're working through, so just bear with me with that as I'm writing them out. Because I want to work through some problems that are somewhat similar to what was given to y'all in class, but I'm going to review some things first too, just as to also refresh. So the big things that we learned about today, let me make sure that we can see this okay, is that anything to the 0 power is 1. Anything to the 0 power is 1. So 5 to the 0 power is 1. 256 to the 0 power is 1. Any variable to the 0 power will always be 1. So anything to the 0 power is just going to be 1. The next thing we learned, and to kind of move into one other thing is that if you have a variable or value that's to the 1 power, it's just itself. So 5 to the 1, it's just 5. 256 to the first power is just itself. Just in case we don't remember this from last year, but that just to kind of review that piece. Okay, so the other thing that we learned about today, so this is the first thing. The second thing we learned about today was about negative exponents. So again, I'm going to start with a variable. So if we have x to the negative second, that's the same thing as having it as the inverse, which is 1 over x squared. And if we were to have this as dealing with integers, so let's do 6 to the negative third. That's the same thing as saying 1 over 6 to the third, and then you would simplify from there. Now, we haven't gone over this piece yet, but I briefly showed it today, was what happens though if we have a negative exponent in the denominator to begin with. So something like 1 over 5 to the negative second. Well, then we just do the inverse of that as well. So it's just 5 to the second. We just flip it up. And the reason for that is that what happens, I want to make sure I have enough room to write this. What really happens is that we actually put this as 1 over 5 to the second, but if we divide by a fraction, it's the same thing as multiplying by its reciprocal, which is 5 squared over 1. So when we divide by a fraction, this is what we're doing here. We're dividing by a fraction. It's the same thing as multiplying by its reciprocal. So that was the first few concepts that we went over. I feel like the simplifying piece when we're dealing with integers isn't too bad, but I think what we did come into have some issues with is when we had variables. So I'm going to work through some problems that are very similar to the ones that I gave today, and I think I'm going to end up going on a new page anyway, because I wrote kind of big on this one. Okay, so let's start with, let's just go with just a basic variable. So let's just work with y. Okay, so if we have y to the negative 5th power, and I wanted to simplify this as much as possible, we do not like having negative exponents. So let's write it as if we have positive exponents. So y to the negative 5th is just going to be 1 over y to the 5th, and that would be your answer. You would be done at that point. What about if we had x to the negative third? The same thing. We would write it as 1 over x to the third. We want the positive exponents. If it's already a positive exponent, we're done. We'd already be done. I wouldn't give you something like that though. I don't believe. I'll probably give you something like this with other factors though. And that's what comes into play when we have more than one factor. So let's say now we have two factors. Let's do a squared, we'll still use the a squared, and b to the negative fourth, we'll say. So these are two factors. So when they're side by side, right, it's like saying a squared times b to the negative fourth. Well, now that we have our factors separated, we can kind of move these a little bit easier. A squared already has a positive exponent, so I'm okay here. I'm going to leave him. I'm going to focus on this next factor, which is b to the negative fourth. And again, we don't like having negative exponents, so we're going to write the inverse of that. So we have a squared times 1 over b to the fourth. Now we just put them back together. Now you can do this one of two ways. I typically just go ahead and multiply straight across. We got to remember that a squared we can just put over 1, because anything over 1 is itself. So we can just create a quick fraction like that and then multiply straight across. So a squared times 1 is a squared. 1 times b to the fourth is b to the fourth. And we would be done at this point. It is very unlikely, but you could see it a second way. And I say this, that this is maybe a 1% chance of seeing this. 1% chance of seeing it. I highly doubt seeing it, but you could also see it as a squared times, or actually, I guess in parentheses, 1 over b to the fourth. Because we can simplify this even more to the above answer. All right. That answers about the first two questions from the third section that we were working on from the practice today. There is another question, again, like where you have a negative exponent on the bottom. So if I have a to the negative 10th, again, if it's wherever it is, if it's a negative, you just flip it to the other side. It's the quick way to do that. But again, what's actually occurring, you don't have to go with this. I'm explaining it more than I need to, but what's actually occurring is you're having 1, right? And we're going to write that as the inverse. So 1 over a to the 10th. And when we divide by a fraction, it's the same thing as multiplying by its reciprocal. So 1 times the reciprocal of the second fraction, which is just a to the 10th. Multiply them straight together, and it's a to the 10th. And again, this is the tricycle stuff. This is explaining everything that we're going through, all the processes, just as if we were riding a bike. When you have the training wheels on, you're learning all of the mechanics of the bike. You're learning how to balance. You're learning how to pedal. You're learning how to steer. So I'm showing all of those steps here. And then once we can see these steps and see what's going on, we can just skip that, and just like a bike, we can just ride straight to the end. So if you have a negative exponent on the bottom, we'll just bring it up top and make it a positive exponent. And if it's a negative exponent when it's in the numerator, then you bring it to the bottom and we make it positive. All right, and then again, I should have done this one first, but then we're going to have some more factors. This time I'm going to make it a little bit more difficult. So now let's deal with actual values. Let's deal with 3 squared. We're going to multiply that with a to the fourth. We're going to multiply that by b to the negative third. And c to the negative second. Now again, these are 4 different factors. 4 different factors that we can just separate just ever so slightly and focus on each factor by itself and simplify. So we have 3 squared times a to the 4th times b to the negative 3rd times c to the negative 2nd. And now let's focus on each one. Let's go one at a time. So I'm going to highlight as I'm moving through. So I'm going to work on 3 squared first. 3 squared, what does that equal? 3 squared is going to equal 9. So we get that piece. Let's work on the next factor, a to the 4th. Well, we don't know what a is, so we can't do anything with the variable, and the 4 is already, the exponent is already positive, so we're done. So this is going to stay a to the 4th. I'm going to just slide over just a little bit. B to the negative 3rd. B to the negative 3rd. Well, we have a variable. We don't know what it is, so we're going to keep that variable. But it's to the negative 3rd. We want a positive exponent, so we're going to go 1 over b to the 3rd. And then we're going to multiply that by our next factor, which is c to the negative 2nd. I hope this doesn't cover up too much. Ooh, that's not very easily seen. Let's change the yellow. So c to the negative 2nd. Again, we want a positive exponent, so we're going to put 1 over, we're going to write the inverse, 1 over c squared. And then we're going to just multiply them straight together. 9 times a to the 4th. Actually, I'm going to run out of room over there, so I'm going to write this below. 9 times a to the 4th is 9 times a to the 4th. B cubed times c cubed is b cubed times c cubed. I'm sorry, c squared. I apologize. That's c squared. So we just multiplied these all straight across. And again, remember, an integer is just over 1. And our variable is just over 1. So we can just multiply them straight across. 1 times b cubed times c squared gives us our denominator. 9 times a to the 4th times 1 gives us our numerator. So this would be our answer. All nice and simplified. Right, let's work on another one. Again, we're not evaluating though at this point. We're simply just we're just simply simplifying. So we're not doing that extra step of when we need to evaluate given when we are given what the values of those unknowns are. I should have numbered these. Let me number these real quick. So let's do this. It's 1, 2. We'll call this 3, even though that really wasn't 1. 4. This is 5. This is 6. And these are not in relation to the practice that I gave today. I'm just numbering these in case, just for me as I'm going through. Now, what happens if we have an integer and we have negative exponents in both the numerator and the denominator? So let's do something like 5x to the negative 3rd over y to the negative 2nd. What would I do here? Well, again, we could, if you want, break up these factors. There is the shortcut, as we discussed with number 5, where if it's a negative, we just flip it. But let's actually see what's going on. So I'm going to break these factors up. What's happening is, and you can write your factors in a different order. You don't have to write it in the exact order that I'm doing it, because if you're multiplying using the commutative property of multiplication, we can move these factors around. But I'm just going to move left to right and then top to bottom. So the first factor I see is 5, and that's multiplying to the x times x to the negative 3rd. Now what about this bottom one? Well, that's also like multiplying 1 over y to the negative 2. So now we've separated. You do not need to separate it like this. I will show you another way, as I discussed with using the shortcut method with 5, but this is what is occurring right now. So paying attention to my factors, I still have 5. He doesn't have an well, he has an exponent of 1, so we don't have to worry about that. X to the negative third is going to be times 1 over x to the third. And 1 over y to the negative second is just going to be y to the second. And then we can multiply those straight across. Put my 1s on just to show you that we are just multiplying by 1. So what we're left with is 5y squared over x to the third. Now, the shortcut, what I would have done, knowing what's going on between these factors, is that I see a negative exponent, so I know if it's a negative exponent, we're gonna flip it. So it's gonna be 5, flip the y, flip the x, we still get the exact same answer. So that's how I would handle the part 3 of the simplifying the expressions from the practice today. Now, if you have to evaluate, that's going to be just a little bit of extra step. So I would recommend simplifying first and then evaluating. If we happen to be given values for this at that point, then we would just plug them in. We would plug in what those values are. So I don't have really room to evaluate here. So let's go to another page real quick. For the time being, I'm just going to use x and y. And I'm going to say if x equals, I'm going to use easy numbers 2 and y equals -3 for right now. Okay. So let's say let's do like, I'll do 3 problems and then I'll stop there for you, so I'm not boring you all to death. So let's do one where we have quite a few factors. Let's use the example kind of like what we used the last one. Let's use this time though I'm gonna make it 4. We'll use x to the negative second, y to the negative third. Why did I do it like that? we'll use negative second for this one. We'll use this to negative 4. I switched it up a little bit. And I'm going to move this out of the way so we don't get confused. I apologize for having to do so much extraness to begin with. So for every single one of these, we're going to evaluate using x equals 2 and y equals -3. So in my opinion, I would honestly simplify first before you substitute anything in. So let's rewrite this. I'm going to use the shortcut method. I see this -4. I see this -2. So the y is going to come up top. And I'm going to get y squared. So this -4, the x is going to come down. And we're going to get x to the 4th. Now I would substitute in our values. So I have 4 times -3 squared over x to the 4th, which is 2 to the 4th. -3 squared, and I'm going to break this up bit by bit, is going to be 9. 2 to the 4th is going to be 2 squared is 4. We're going to do that twice, so that's going to be 16. We're now going to multiply. Now you could do one of two things. I see that 4 is a factor of 16, so I could cancel this right now. I could cancel the 4 already, or in fact, well, you could do that, or you could do it later. If you see that 4 is a factor of 16, we can factor that out, and we're left with 4, and so we would be left with 9/4. If you see that. If you don't, If you do not, what you can do instead is still continue through. 4 times 9 is 36 over 16. And then we can do this, we can do slow factoring. So if I see that these are even, so we could factor out a 2 each time until we get to our answer. Or if you knew, you can see that these are both a factor of 4. You can do that and you'll still get 9 to the 4th. Either way is fine. Let's do another one. Let's do x squared y. Let's do y to the negative 1, because that may happen as well. So let's simplify first. X is already fine. It's already got a positive exponent. And y is to the negative 1, so we can just write that over y. And that was a shortcut. So how did I get there? How did I get there? So just in case, you want to see that step in between? It's x squared times my other factor. Y to the negative 1 is just going to be y over 1. And then we multiply straight across. Remember that this is going to be over 1 because it's in the numerator. X, or anything divided by 1 is just itself. X squared times 1 is x squared. 1 times y is just y. Now substitute your values in. So we're going to put 2 squared over negative 3. 2 squared is going to be 4. And I'm just going to put the negative sign next to the fraction bar, because a negative divided by a positive, or positive divided by a negative, I'm sorry, is a negative. That would be our answer. We'd just stick with that. Notice that you are not going to just put this in the calculator and get decimals. You will not be doing that. Well, we want the fraction form. Right, let's do one more, I think. Yeah, let's do one like... So this is very similar to number 10. I had a question on this one. What happens if you have a negative variable and then you're going to raise it to a negative exponent? So for this one only, I would substitute your value in first. Okay, so my value is 2. So I'm gonna substitute 2 in. It's a negative x, and so the opposite of x, which is 2, so the opposite of 2 is going to be negative 2. Now I'm going to simplify this by getting rid of that negative exponent. So it's going to be 1 over negative 2 squared. Please make sure, if you're going to use Desmos to evaluate negative 2 squared, that you put it in parentheses, because otherwise it will tell you it's a negative, and that's not true. This is negative 2 times negative 2, which is positive 4. So it's 1/4 would be this answer. And they're not the exact questions from the practice today, but I think they're good representations of what you would be dealing with. The values would just be different. If you do have questions, please let me know. I hope you're doing well, and I will talk to you later.